Hey there, and welcome. So today we're diving into one of the most common shapes you can possibly think of, the circle. Yeah, I know, it looks simple, right? Maybe even a little basic? But trust me, locked inside this one simple shape are some of the most elegant and kind of mind-blowing rules in all of mathematics. Let's start cracking them open. I mean, think about it. You see them everywhere, in wheels, clocks, the moon, you name it. But have you ever really stopped to think about the strict, invisible laws that govern every single line and angle you could possibly draw inside one? Well, that's what we're doing today. We're going to go on a little treasure hunt to find those hidden rules. Now, to unlock any of these secrets, we've got to learn the lingo first, right? We need to know the circle's basic language. Don't worry, it's just a few key words that'll help us figure out what's going on. Okay, first up, a chord. Just think of it as a straight line that connects any 2 points on the circle's edge. It's basically a shortcut right across the middle. Next, you've got the tangent. Now, this is a line that just skims the outside of the circle. It touches it at one and only one single point before it keeps on going. It's like a gentle little tap, not a slice. And finally, the secant. If a chord is a shortcut that stays inside the circle, a secant is like a highway that just plows right through it, hitting it at 2 different points. So we've got chords, tangents, and secants. Got it? Good. Now we're ready for the really cool stuff. All right, time for our first major discovery. This is a huge one, a really foundational rule about how angles behave when you draw them inside a circle, and it's surprisingly simple. So let's picture 2 different angles. They both open up to the exact same piece of the circle's edge, what we call the same arc. One angle starts from the very center of the circle. We call that the central angle. The other one, its corner is right on the edge of the circle. That's the inscribed angle. So the big question is, what's the relationship between their sizes? And here it is, the first secret, and it's just beautiful. The inscribed angle, the one from the edge, is always exactly half the size of the arc it's looking at. So if that arc is 80 degrees, the angle is a perfect 40. Meanwhile, the central angle is always the same as the arc. So simple, right? That half relationship is our first key. Okay, that first one was cool, for sure. But this next secret, oh man, this one is, in my opinion, the most beautiful and totally unexpected of them all. And it brings together 2 of our new vocabulary words, the tangent and the chord. Okay, so picture that line that just kisses the edge of the circle. That's our tangent. And right at that single point of contact, we draw a chord that cuts back into the circle. And right there, where they meet, they form an angle. Now, you might think that angle is just kind of on its own, right? Stuck on the edge. But nope. It's secretly connected to the entire rest of the circle. And here's the big reveal. That little angle where the tangent and chord meet is a perfect exact copy of the inscribed angle way over on the opposite side of that chord. I mean, how wild is that? They're identical. It's this surprising link between an angle on the edge and an angle all the way across the circle. So why on earth does that work? Well, instead of getting into a super dense mathematical proof, let's just try to feel it out. Imagine that inscribed angle on the far side. Now, in your mind, slide the corner of that angle along the circle's edge, moving it closer and closer and closer to where the tangent touches down. The crazy thing is, the angle itself doesn't change size as you slide it, but visually it just sort of morphs until it becomes the very same angle formed by the tangent and the chord. It's a really elegant way to see why this has to be true. All right, so we've unlocked secrets about angles, but you think the circle is done? Not even close. It also has some incredible secrets that involve, of all things, multiplication, and they pop up whenever lines start crossing each other. So first, let's check out what happens when 2 chords cross inside a circle. This intersection point splits each chord into 2 smaller pieces. And here's the magic. If you multiply the lengths of the 2 pieces from one chord, you get a number. Now, if you do the exact same thing for the other chord, you get the exact same number. It's wild. It works every single time. Part A times part B is always equal to part C times part D. A perfect hidden balance. And there's another multiplication rule, this time with a tangent and a secant that both start from the same point outside the circle. It's a little different, but just as cool. For the secant line, you multiply the part that's outside the circle by the entire length of the line. For the tangent, you just multiply its length by itself. You square it. And what do you know? Those 2 values are always equal. It's another one of these perfect hidden relationships. So think about it. In just a few minutes, we've gone from looking at a simple shape to uncovering this whole set of powerful rules.
And these aren't just, fun trivia. These are the actual tools that mathematicians and engineers use to build and understand the world.
So let's quickly recap what's in your new geometric toolkit. You've got the inscribed angle rule. An angle from the edge is half the angle from the center. Simple. The tangent chord theorem. The angle of touch is the same as the angle on the opposite side. You've got the intersecting chord theorem. Part times part equals part times part. And finally, the tangent secant theorem. The outside part times the whole thing equals the tangent squared. Pretty powerful stuff. What all this really shows is that we started with a shape we see 100 times a day and found this whole hidden world of elegant, predictable, and powerful rules just sitting there. It really makes you wonder, doesn't it? What other secrets are just hiding in plain sight in all the other things we see every day, just waiting for us to get curious and ask the right questions? Thanks for joining me on this one.